Okay, now it should work. Well, I can straight start with the presentation if you want.
Would you introduce yourself?
Oh, sorry, I missed that one. Yeah, sure. So yeah, okay. I'm Yuri. I'm from South Tyrol, Italy, and I'm a full stack developer. And today we're going to talk a bit about testing in Angular, and mainly because I recently took a look at Angular and testing in specific, because last time when I looked at it, it was about when the first beta came out. So I wanted to see what changed, and that's more or less today an experience report, what I encountered, like more like an introduction basically to testing.
Okay, so we're looking forward for your talk. Let's go.
Okay, great. So let me share the screen with you. Do you see my screen?
Yes.
Awesome. Okay, so as I said, we're going to take a look at testing with Angular, and I want to give you some recipes basically. Now, if you want, here are the slides. Basically, I already took them online because I know often Hangout has some problems. Also, if you encounter problems throughout my talk, just say something so that I'm not speaking with myself alone. And yeah, so let's start directly. So first of all, I don't know whether you heard about the It's Just Angular movement, which Igor himself is quite pushing on Twitter. So basically, they removed the version 2 from Angular, or they tried to remove it because they are releasing now Angular 4 actually in March. And because they are following the whole Semver story, and therefore, obviously, Angular 2 wouldn't make any sense. So therefore, it's just Angular. And this talk, however, is starting from version 2 onwards, just to give you a heads up on this. Well, as I said, who am I? I'm Jure Strumpflohner. On Twitter, you can find me here on this handle. It would be cool if somebody gives me a shout there or connects with me. It's always nice to see. I'm from South Tyrol, Italy. As you can see, we have a lot of skiing areas around here. Although this winter, it's quite difficult right now. But we should get some more snow in the following weeks, hopefully. So when I'm not coding, basically, I'm also blogging a lot about Angular recently, specifically, but not only. This blog here. Just give it a look if you want. I have a lot of articles there, and I always love to get feedback or improvement suggestions, so just go there and comment. And yeah, when I'm not coding or blogging, I'm flexing with Igor, which I was happy to meet him at one of the last conferences here. So great. What I wanted to talk, as I said, is how do we write unit tests with Angular? So not testing in general, but today I would like to focus on unit tests in particular. Now, from a tooling perspective, what we need, first of all, is Jasmine. Jasmine is basically a testing framework which allows us to write JavaScript tests in a behavior-driven manner. You can find it at this link here. It has quite some good documentations up there. And a basic Jasmine test looks like this one. So you have a describe statement at the very top, which defines your test suite, basically. Then you have here such a before each, where you do usually the whole setup story of the object you want to go to test. Then you have the single test statements here, where you basically execute the method which you want to test, and then you have so-called expect statements and these matchers, which basically verify the state of your object you are testing. And then eventually you have these after each statements where you can, again, reset the state of your object or clean it up. But these ones are actually used fewer times in the test we will see. The next thing which we need is Karma. Karma is basically a test runner which allows us to take for instance, our Jasmine tests and run them in a browser, even a real browser like Chrome or Firefox. And then it gathers back basically the results and visualizes them in our console or in our CLI if you want. And finally, obviously, the Angular CLI. I specifically took that one because we're lucky to have this one because it sets already, it basically does already the whole setup story for us. So we don't have to care about how to set up Karma, how to set up Jasmine and so on, but it does already the stuff for us, which is really nice, especially if you're just beginning and you don't want to deal with all the tooling stuff. So if we take a look, for instance, quickly at my setup here, what I have done is exactly to use the Angular CLI and to generate a simple scaffold. And if we take, for instance, a look in the package.json here, we see already there are some scripts which are for running the tests. And so we can just execute, for instance, npm run test.watch. Let's take that one, as that one will then watch the files which I'm going to change behind the scenes and recompile them and rerun the tests for me. So as you can see, it is going to compile behind the scenes. It uses Webpack. And now we should get a result shown basically about the tests which I have already in this repository here. It opens a browser. Here you can see the Karma, which connects with Chrome in this case, and it executes my test cases. And the major important file here also is the Karma configuration here. So if you want to change anything on how your Karma tests should run in the browser, which plugins you want to use, then you go in this file here basically and you adjust them. Like I did, for instance, add this Karma Mocha reporter, which I then set. And what it does is basically to show my test here in a bit of a nice tree structure, showing also the names of the test suites, of the test cases, and then green or red ticks basically whether the test failed or not. Great, so much to the testing setup. Now, I would like just to go through some of these keywords which you can see here on the screen. So these are those which you will most probably encounter when you're going to test with Angular. And hopefully by the end of this talk, those say something to you, so you know more or less where to get started. Okay, so let's first talk about testing services, because I think they are probably easier to test than the other things in Angular, like, for instance, components. So as you might already know, this is a basic service. So we basically have some injectable, which we get here from the Angular core, which is here a decorator, which Angular uses for dependency injection. And below here, we have a very simple ECMAScript 6 class, which here happens to be TypeScript, as you can see. I'm defining here some types. And then I'm returning basically just a string, which takes that name parameter and concatenates it and returns it. So actually quite simple. And the nice thing here is basically that when we are going to test such a service, we could simply grab the service type, so import it. And then before each statement, we can simply instantiate that service. We reference it in here in a local variable. And then in the if statements, we basically can write such an expect statement where we say hi, I pass in Yuri, my name here, and I say it should be equal to hi Yuri. And that's it. So actually really, really simple. And many times this is also an option to actually do in Angular as well. However, there's another story in Angular, which is mainly the dependency injection thing. So we don't always have such a simple service only where we basically have no dependencies at all, but usually we have external dependencies which we might want to mock out, and therefore dependency injection is quite useful. And as you might know, in Angular 2, we have this kind of module. So the module declares basically what our imports are, the components, for instance, and also eventual providers like services. And this allows us to configure a module within Angular. Now, in the testing part, we have a similar thing. Like here we have the test pad, which is like a functionality, a utility, which we can use throughout our test cases. And the test pad has a so-called method here, configure testing module. And this allows us to pass in a JSON structure, so a JavaScript object here, which is exactly structured like the ng modules in Angular, so the module which we have seen here. But just in this case, we can only configure those parts which we need in that specific test case, for instance, our greeting service. We don't have to provide anything else unless our greeting service requires to do so. So if you now take a look again at our test, we can change it slightly. So instead of instantiating the greeting service directly, we can now use that test pad. We have here the providers part where we give it the greeting service. And then further down, we can then use the test pad again to get an instance of such a greeting service. And now we would also get any kind of dependencies that greeting service requires, and nicely set up for us in that service variable here. There's another way as well. So instead, basically, of having here the test pad and manually grabbing it via that get function, we can also have a separate before each. So first, the one where we configure our testing module, and then we can use that inject construct from Angular and inject the greeting service in this case, and reference it again. You can also use that inject within your single it statements, which often might come in handy if you just need another service which you need to inject and configure. But this is mostly up to preferences, which way you want to use. Okay, so let's take a look at some more concrete examples, some more interesting example maybe. So here we have a service which does some asynchronous stuff, which is mostly what you happen to encounter in JavaScript applications, obviously, because we don't have only those simple services which don't do any async stuff and just return a function or something like that. So in this case here, I did probably the most simple async stuff you can do in JavaScript, which is a set timeout, which after 100 milliseconds resolves this promise here and returns here the word simply hi there. Now, if you want to test this, we might do it, for instance, like this one here. So let's, for instance, take a look at the code here. Let's take the async service here. And again, you see here this testing service. So this testing method here where we test the async service. I hope you can read that.
Yes.
Perfect. Now, if you execute the test, this looks quite straightforward. So we have here an async behavior. We expect here to get here hi there, just as we specified our service. And the test passes. As you can see, I don't get any errors right there. However, if I do something like that, you see the test will recompile and re-execute. By the way, you can also make this a little bit faster by prefixing it with that F, and that way we will only execute that single test case. It's also often quite useful. And now you can see that actually our test case fails. So further up there, I saw here one test case failed. And the problem here is that the test will pass through and it won't execute this one here because the test exits without any expect statements, and so Jasmine says everything went fine because a test without asserts basically is a successful test. And the problem is actually that this test case is asynchronous. So this line here will happen after the test has already finished. And Angular has a nice construct here, which is that async. You can import and simply wrap around the test case. So behind the scenes, Angular will automatically figure out that this is an async behavior and therefore wait for the async stuff to finish first before exiting the test case. And now, in fact, you can see here a message which says hi there, and it doesn't match actually the test case on this side because it says expect hi there, and I got this one here. This is quite a nice property of Angular by just wrapping our test case with that async keyword. So therefore, here warning, watch out, and add that async keyword in the middle. We have also another one which is called fake async, and this gives us even more control. It is used much less, and normally you can just go away with async keyword, but if you need more control, you can actually use that fake async. And what it does is basically it makes our entire test cases, even the async behavior, completely synchronous. So therefore, what we can do here is to define here a variable again, like value. We can invoke our simple async. We register here as a promise, and then we assign here the value on top. And then we can say, expect the value not to be defined. So initially, that value should not be defined because this part here has not been executed yet. Then we have this tick keyword, which allows us to increment the tick to the timer behind the scenes, basically, of JavaScript. So we say increment it by 50. Again, it should not be defined because we set in our timer that only after 100 milliseconds it should execute our callback here. We do another tick and we arrive at 100, and then here basically it should be defined. And in this way we can then that also our timer correctly works, or our asynchronous behavior, which might do some particular stuff, correctly works. So this is quite rarely used probably, but in some cases it might be really useful. Okay, but what about remote XHR calls? Because usually in our services, we go and call our backend side for some API, we gather some results and would like to test those. So for instance, let's take here our remote service. Here we have the usual HTTP service, which we import from Angular, which does basically the asynchronous call. And then I have here a simple stupid method here, fetch via HTTP. I have some endpoint like people.json. And this is the way basically you do it in Angular. You invoke that get function on HTTP, and then you map it to JSON. So basically the result you get back. And here we get an observable, which is that can then be consumed by someone which is using our remote service. Now what we could do is simply something like that. So again, we have the async keyword, obviously, which we have just seen. Then we invoke that fetch via HTTP function here. We subscribe. This is a function of the observable. We should get here some data, and we expect that data.name should be Yuri. Now, most probably, the test here will fail. And the problem is because obviously behind the scenes, this one here is going to do an actual HTTP call over the network. And most probably we won't have any server listening and responding to our HTTP call. So therefore, what you usually do is to mock that part out. Because what we want, or what is an important property of unit testing, as you might know, is that they are really fast. So we don't speak here about integration testing, where we maybe want to call our backend and we have to set it up and clean it up again after our test run has passed by. But in this case, in the unit test, we want to have them really fast. So therefore, we want to take those actual XHR backend calls out of our way and return the result we want to have in our test case. That's also very useful because we can then test some very subtle edge cases also. And Angular has here the mock backend, which you can import from the Angular HTTP testing package. And the mock backend is basically a fake backend, as the name says already, which we can control. And what you see here is that we register our remote service again in the providers part of our testing module. We now have also to import the HTTP module, because that's where basically the whole HTTP stuff resides within Angular. And what we also do here is we override a specific part of Angular. So this is the dependency injection part here, where we say, whenever you need basically that XHR backend, which our HTTP service will use instead this class here instead of the default one. Then what we can do, we can grab that mock backend class that has a connection property. We can subscribe to that connection property. And within that one, we get such a mock connection. And here you can see that we have such a mock respond, where we can then pass in the JSON structure which we want to return in that specific test scenario. So if you then put everything into one test case here, we again have here stupid test should return the JSON which we desire. We first mock our statement within that specific test case. And here we say should return this name Yuri structure. And then down below, we can just simply register as we would like to do. We register to the service, to the fetch via HTTP, assert this statement. Again, obviously, we have to use the async because behind the scenes, this is an async behavior which is going on here. But what about components? So obviously, in Angular, we have lots and lots of components. So let's also take a look at that one. Similar as with the service part, also in the components part, we obviously have to use, again, our testing module here. But now we don't use the providers part, but obviously the declarations part, because that's where our components should be registered in Angular modules. And here I have a simple input component. And what's more important here is that compile component statement. So that's what we also have to attach to our test bed when we use the components, when we use component testing, basically. And what this does is it basically takes in eventual external templates or HTML parts or CSS parts and compiles our component that makes it ready for us. Then once we have done that setup, we can again use in the same test, basically in an order before each, we can create a component instance by using the create component function, always again on that test bed. And what that gives us is a so-called component fixture. That's another important class there, because this one will be used in our test cases to inspect the state of our component. For instance, we can just down below here also add here gather the actual class, so the component instance, which you can use via that fixture component instance property here. And then we run here a change detection cycle over that fixture. We'll take a closer look at that one here. Great, so one scenario could be to test an input. So a very simple case, we have a component with an input. For instance, this one here, we have that input component. An input is basically something that can be passed from the outside into the component. And in this case here, it's a simple message property, which is a string. And then what we do here, we bind it to the template of our component via that curly braces. So really simple component, actually. Now, if you want to test this one here, and let's switch here into our code base here. You see again our method. I just commented this out. Let's add this in again. So when we want to what we want to inspect in this case is basically that our component, which is this one here, whenever we give it some message here, it should be rendered out correctly in the HTML part of the component, which is the template, right? So what we do is, in the first place, before we do anything, we just say, initially the template should be empty because we didn't pass any kind of message to our component, so we shouldn't have anything inside the template, so inside the HTML part. And that's exactly what we do here. We can again use the fixture, and we use the debug element, which is a specific property of our fixture that allows us to inspect the underlying element which our component renders. And then we can access the native element, which is actually the browser DOM part. And then starting from here, you can see we can use the native browser APIs. So for instance, in this case, inner HTML, or we could also use inner text in this case. And we say it should be empty. So it should be an empty string. Right after, what we do is we could now test that input. So we can simply use the component here. And this, if you remember, is nothing else than the component instance, so the class. And since our input is nothing else actually as a class member, so if you, for instance, for a second forget that decorator here, which may seem a bit strange initially, this is nothing else than a simple property of our ESX class here. And that's exactly what we can do. So we can grab that component instance, we can access it message property and set a value to it. And finally, what we do again is we simply access the debug element again, just as we did up there. We inspect inner HTML, and now it should be high there, obviously. Let's save this for a second. It should execute our test cases again behind the scenes. Let's quickly interrupt this and restart again, because often I have some issues that the test cases are running slowly. Still have to figure out why that happens. Again, it opens up Karma. And as you can see, the test case, however, fails. Now, this is probably not something we expected initially. So what we get here is it says we have an empty string, but rather we want high there as we specified here. And the problem is that change detection cycle, which we mentioned briefly previously. So what we have to do whenever we set some property on our component class, we have to run the Angular change detection, which synchronizes the properties of our class with the component's template, so with the HTML part. Previously, maybe, we can use that detect changes. If we run this again, now the properties should be synchronized with the template, and our test case behind the scenes should pass. Now, while this runs quite slowly, I want to mention something else here. Often what can happen is that whenever we run your change detection cycle, you may have async behavior as well. So therefore, what you can do is the fixture detect changes has a when stable, which is basically a promise, which says whenever the change detection stabilizes, then execute this callback here. And so you could wrap this inside here. In the case when this one provocates some async behavior, then you can wrap it inside the when stable to basically only execute the assert after the change detection cycle has completed. But in most of the cases, this is sufficient, so you don't have to use it. But just be aware that if you have strange effects, this is the way to go. Okay, our test passed again, so we are fine. Our change detection cycle worked correctly. Also, what's important to note is that you have different ways within your test to access the underlying DOM. So we can either do it through the debug element, which is somehow the suggested way by Angular, because what it does basically is to somehow mask the underlying DOM part. So for instance, if you take a look at this one here, we don't execute any kind of native APIs until here, because as you might know, Angular is also able to run on like server-side parts where we don't have an actual DOM underneath. So that therefore, you probably should go this way. And the other way is to access directly the native elements, and here use the browser API, such as the query selector, which is just a normal browser API part. So you can use that one whenever you know safely that you will always execute in a browser environment. So this should just work fine. Great, so similarly, we can also test the output. Output parts in Angular are nothing else than events. So we use the event emitter here. And what I have in this case is a simple template with a button. And whenever I click that button, a function is invoked, which is a function here of our component. That function does nothing else than on our output, it basically broadcasts an event using that emit, and it returns the string hi, so really simple. And for testing this kind of behavior, we have different kind of strategies. So first of all, we can simply subscribe to that one. So we can again take the instance of our component class. We have that output greet, which is again just a simple property. We subscribe to it, and then we can execute the expect statements. So we say that what is being returned here should be hi, the string hi. Initiate that broadcasting of our greet emitter here, of our event emitter. We can then obviously invoke simply our function, which we have just seen here in our component. So this is one way of doing it. The other way is to invoke, to basically provocate a click on that button, which you have seen, which will then, behind the scenes, invoke the doGreet function and emit our event. The problem there, however, is how do we know that the emit event has been fired? Now, we could again either directly subscribe to it, or we could also use a property of Jasmine, so the testing framework, which are so-called spies. So we could simply say spy on that greet function, that greet output property, and especially on that emit function, and monitor how many times this is being called, for instance. Then here we again use the native element of our fixture. We use the query selector to get an instance of our button, of the DOM element here, and then we execute a click event on that button. Now behind the scenes, our event will be fired, and finally then we can then say expect component greet emit to have been called with hi. So this is another quite nice way for listening to event emitters, basically whether they are fired and whether the properties with which they are fired are correct. And the third way, which I have found by browsing through the Angular source code, is to directly trigger an event on our component, because the nice thing is that output events on Angular components are nothing else as normal events, basically, just as a click event, for instance. So again, what we do here is the same as in our first test scenario. We subscribe to our output, and then we can use the debug element again to trigger an event handler, and in specific to trigger the greet event handler. And this is the same way. So once we execute this one here, our event emitter here will be fired, and we can execute then that expect statement. And the final part, which is also quite interesting, which I would like to show you, is to mock components. Because what we might often have is obviously not just such simple examples as I have shown you here, obviously, but we have big components which we want to test, and in the middle there might be a lot of other components. For instance, here, my collapsible panel or some other kind of behavior. And now testing all of those as a whole might become quite complex and might be quite difficult, and especially it might also connect the different test cases together such that either all of them are failing because a single thing doesn't work, or or all of them are passing. So we would like to decouple usually our test scenarios to focus just on the single component we would like to test. But also here there are different kind of strategies. So we could obviously basically say just get all of them. So I reference all of the needed collapsible panels and other components which my main component, which I'm going to test, might depend on. And that might just be fine in most cases. And what we could also do, however, is to provide just our own versions of those subcomponents. Like for instance, that collapsible panel here, override it with such a version. As you can see here, the template is simply empty and it wouldn't do anything. And then I can provide it basically and register it, sorry about that, register it to our declarations part here. In this case, I would basically have provided a fake instance of such a collapsible panel. The other way is to basically mock nothing. So to do not specify anything, to not provide any of those dependencies which my nested component test might need. And the problem, however, is that whenever you execute that one just out of the box with Angular, Angular will throw an error because it will say it encounters some other components, some other HTML elements which it doesn't know. So you have to either provide them. Or the other part is that you could use that no error schema. So with this one, we can simply say, ignore all of those errors and just go on. So ignore all of those components which you might not know and just execute. And this might come in quite handy, actually. Great. So I hope this wasn't too tiring or too boring, because I actually have thrown quite a lot of code to you. There will be actually a lot more even. So I didn't cover like testing routes or writing custom matchers or testbed helpers, which especially these parts here might be quite useful because they might facilitate the life or make your life quite easier when it comes to testing components, because you can write a lot of helpers like matching styles or matching CSS classes as well. And another important part is also the end-to-end testing with Protractor. Is just to test basically unit the single parts, like the single components or the single services. But another part is also the UI testing. So Protractor is something written by the Angular team already for Angular 1, and they are actually porting it, or better said, it actually works now also with Angular 2. And what it allows you is to test basically components in UI components in an automated way. Sorry. So for instance, if you take a look here at the setup of our Angular CLI generated part, in the package.json, you actually have already this E2E script, which uses Protractor behind the scenes. And you have even also some tests inside here generated. And if you could just quickly open them here, without going into much detail, you see they're quite written in the same way as our normal adjustment tests, which we have just seen. Is that inside those Protractor tests, you have instances like, for instance, the browser here, which allows you to navigate or control a real browser. So basically to open different kind of URLs, navigate to different parts of your application, and then again do such asserts and whether they match or whether you see what you expect actually. But I don't want to go too much into those details because it would be probably a topic for a total different talk, a total knowledge talk. Great, so I hope now these keywords do tell you something so that you have some starting point, where to get started, where to dive in deeper into those testing things for Angular. I actually have also provided this repository here. So if we quickly go, let me grab a browser instance here, to that repository, you will find all the examples which I have shown you here and a lot of more of them. So like testing input output, also how to manipulate the DOM, how to test content projection. I've prepared an initial set of some potential useful tests. I have also linked here quite some interesting articles, like from Gerard Sanz, or also the Thought Run guys have just written up a very interesting article on how to write custom matchers, which you actually see inside here an example. And just 5 minutes ago, I think Victor also published an article on essential Angular testing. And I haven't read it yet, but I think there are a lot of useful stuff obviously from him. So you may also take a look at this one. I will link it afterwards then in the repository. Great, so that was it. Thanks, Hamburg. Just let me switch back to stop the screen sharing. Okay.
Okay. So you mentioned that you are available for a few questions.
Yeah, sure.
So if you have questions, feel free to ask. Yes, I will. Maybe, at least I will. So you asked for a link for the GitHub repo. So at least I will
Oh yeah,
post it in our GitHub. So
yeah,
in our meetup group. So I will.
exactly. I will send you the link basically to the slides as well as to the GitHub repository. And if everything worked to right, the talk should also be recorded and be available afterwards on YouTube. So
Okay. Yeah, cool. So, questions, or are you back?
I bored you to death, basically.
I was wondering about the execution speed of the tests. Is it rather slow because these are pretty simple tests? So what's the cost for this?
You asked for the cost for the low speed of your tests.
Well, that's actually something I actually didn't figure out yet. It only happens sometimes. So normally they run fast, and sometimes they basically start staggering. And if you restart basically the Karma server, they then run fast again. So either it's an issue with Karma itself, or it's an issue with the Angular CLI. I still have to debug it because it just happened today. It started getting slower, or it's also probably, or maybe a problem with my machine itself. So I have to figure it out, but it shouldn't be like a bigger issue, I hope.
Or some questions about the topics, or so all guys are happy.
Awesome.
So I thank you for your talk. So I have to go to the camera. Thank you. We enjoy it. And yes, we meet at Twitter.
Yeah, would have been nice if I could actually come to Hamburg, because virtual beer is not that good as real beer, I guess. So yeah, maybe next time.
Yeah, you're welcome. Come, and we find the location where you can stay at the time.
Yeah, sure. Let's do that.
Yeah.
So bye. Enjoy the rest of the evening.
Yeah. Bye.
Bye.